To determine the appropriate conductor size for feeding a pump system with multiple motors, several factors must be considered, including the full load amperage, or flaw, of each motor, the number of current carrying conductors in the conduit, and the applicable derating factors. In this scenario, we have 5 motors, each rated at 1/2 horsepower, and each motor has an FLA of 2 amps. The conductors feeding these motors will be run in a single conduit from the load center to the pump control panel. The first step is to determine the total number of current carrying conductors. Since each motor has a 3-phase power supply, and each phase requires a conductor, there are 3 current carrying conductors per motor. With 5 motors, this results in a total of 15 current carrying conductors in the conduit. According to the National Electrical Code, NEC, when the number of current carrying conductors in a conduit exceeds 3, the ampacity of the conductors must be derated to account for the increased heat generated by the conductors. The NEC provides tables such as NEC Table 310.15. B3. A. To determine the appropriate derating factors based on the number of current carrying conductors. In this case, with 15 current carrying conductors, the derating factor is 50%. This means that the conductor's ampacity must be reduced to 50% of their listed value. To calculate the required ampacity of the conductors, first determine the total FLA of all the motors. Since each motor has an FLA of 2 amps, the total FLA for the 5 motors is 5 times 2 amps, which equals 10 amps. However, the NEC also requires that the conductors be sized to handle at least 125% of the largest motor load, plus the sum of the FLA of the other motors. In this case, all the motors are the same size, so the largest motor load is 2 amps. 125% of 2 amps is 2.5 amps. Adding this to the sum of the FLA of the other 4 motors, which is 8 amps, results in a total required ampacity of 10.5 amps. The next step is to apply the derating factor to the conductor's ampacity. Since the derating factor is 50%, the conductors must have an ampacity that, when reduced by 50%, is still greater than or equal to 10.5 amps. To determine the minimum required ampacity of the conductors before derating, divide the required ampacity after derating by the derating factor. In this case, divide 10.5 amps by 0.5, which equals 21 amps. Therefore, the conductors must have a minimum ampacity of 21 amps before derating. Now select conductors with an ampacity of at least 21 amps. The specific conductor size required will depend on the type of conductor and the installation conditions. Consult NEC Table 310.16 to determine the appropriate conductor size for the given ampacity and conditions. For example, if using type THHN copper conductors with a temperature rating of 90 degrees Celsius and installed in a raceway, a number 12 American wire gauge or AUG conductor has an ampacity of 30 amps, which is greater than the required 21 amps. However, it is important to consider the terminal temperature ratings of the equipment to which the conductors will be connected. If the equipment is only rated for 75 degrees Celsius, the ampacity of the conductors must be based on the 75 degrees Celsius column in NEC Table 310.16. In this case, a number 12 AWG THHN conductor has an ampacity of 25 amps at 75 degrees Celsius, which is still greater than the required 21 amps. In summary, to properly size the conductors for this pump system, firstly determine the total number of current carrying conductors, which is 15. Secondly, calculate the total FLA of the motors and apply the 125% rule to the largest motor. Thirdly, apply the derating factor of 50% due to the number of current carrying conductors. Fourthly, select conductors with an ampacity that, after derating, is greater than or equal to the calculated load. And fifthly, consider the terminal temperature ratings of the equipment and adjust the conductor ampacity accordingly. It is also important to ensure that the conduit is properly sized to accommodate all the conductors. The NEC provides tables such as NEC Chapter 9, Table 4, to determine the maximum number of conductors allowed at a given conduit size. In addition to the conductors, a grounding conductor must also be included in the conduit. The size of the grounding conductor is determined based on the size of the overcurrent protection device, such as the 15 amp circuit breakers in the load center. Refer to NEC Table 250.122 to determine the appropriate size of the grounding conductor. For a 15 amp circuit breaker, a number 14 AWG copper grounding conductor is typically sufficient. When installing the conductors in the conduit, it is important to follow good wiring practices, such as using proper wire pulling lubricant to reduce friction and prevent damage to the conductors. The conductor should also be properly terminated at the load center and the pump control panel, ensuring that the connections are tight and secure. It is also important to label the conductors at both ends to identify the corresponding motor. This will help with troubleshooting and maintenance in the future. In addition to the conductors, the conduit itself must be properly installed and supported. The NEC provides guidelines for conduit support spacing, which varies depending on the type and size of the conduit. Ensure that the conduit is securely fastened to the building structure and that it is protected from physical damage. Finally, before energizing the pump system, it is essential to thoroughly inspect the wiring and connections to ensure that they are properly installed and that there are no potential hazards. Use a multimeter to verify that the voltage and current are within the acceptable ranges and that there are no ground faults or short circuits. It is also recommended to perform an insulation resistance test on the conductors to ensure that the insulation is intact and that there are no leakage currents. By following these steps, you can ensure that the conductors for the pump system are properly sized and installed, providing a safe and reliable power supply for the motors. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidelines. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. Here is an additional clarification regarding the ampacity calculation. The previous calculation considered the total FLA of all motors plus 125% of the largest motor's FLA. This method applies when all motors start simultaneously. However, if the motors start sequentially, meaning only one motor starts at a time, a different calculation is used. When motors start sequentially, the conductors only need to handle the inrush current of one motor at a time plus the running current of the other motors. Motor inrush current can be several times higher than the FLA. The NEC allows for the use of overcurrent protection devices, such as circuit breakers, that are sized to handle the inrush current without nuisance tripping. The conductor ampacity must be sufficient to carry the continuous running current of all motors plus a percentage of the inrush current of the largest motor. The percentage of the inrush current to consider depends on the type of motor and the starting method. Consult NEC Article 430 for specific requirement. Let's assume, for example, that the motor inrush current is 6 times the FLA, which would be 12 amps for 2 amp FLA motor. If the motors start sequentially, the conductors must be sized to carry the FLA of all motors, which is 10 amps, plus a percentage of the 12 amp inrush current. If the NEC allows for 125% of the inrush current to be considered, that would be 1.25 times 12 amps, which is 15 amps. Adding this to the total FLA of 10 amps results in a required conductor ampacity of 25 amps before derating. Applying the 50% derating factor, the conductors must have an ampacity of at least 50 amps. In this case, a number 6 AWG THHN copper conductor, which has an ampacity of 55 amps at 75 degrees Celsius, would be suitable. Therefore, the method of motor starting, whether simultaneous or sequential, significantly impacts the required conductor ampacity. Always consider the starting method and the applicable NEC requirements when sizing motor feeder conductors. Furthermore, consider voltage drop when determining conductor size, especially for long runs. Excessive voltage drop can cause motors to overheat and operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 5% from the source to the farthest motor. To calculate voltage drop, use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current constant, which is approximately 12.9 ohms for copper conductors, I is the current in amps, D is the distance in feet, and Cm is the circular mils of the conductor. Rearranging the formula to solve for Cm, we get Cm equals 2 times K times I times D divided by voltage drop. Plug in the known values, including the allowable voltage drop, to determine the required circular mils of the conductor. Then, consult a conductor ampacity table to select a conductor size with a circular mils value greater than or equal to the calculated value. For example, if the distance from the load center to the pump control panel is 100 feet, the current is 25 amps, and the allowable voltage drop is 5%, which is 12 volts for a 240 volt system. The required circular mils is 2 times 12.9 ohms times 25 amps times 100 feet divided by 12 volts, which equals 5,375 circular mils. A number 12 AWG copper conductor has a circular mils value of 6,530, which is greater than the required 5,375 circular mils. Therefore, a number 12 AWG conductor would be sufficient to limit voltage drop to 5%. However, it is important to remember that the conductor must also meet the ampacity requirement. In this case, a number 12 AWG THHN copper conductor has an ampacity of 25 amps at 75 degrees Celsius, which is sufficient for the 25 amp load. Therefore, a number 12 AWG conductor would be suitable for both ampacity and voltage drop considerations. In summary, when sizing motor feeder conductors, consider firstly the total number of current carrying conductors, secondly the total FLA of the motors and the motor starting method, thirdly the derating factors for the number of current carrying conductors, fourthly the voltage drop, and fifthly the terminal temperature ratings of the equipment. By considering all these factors, you can ensure that the conductors are properly sized and installed, providing a safe and reliable power supply for the motors. And always consult the latest edition of the NEC and local electrical codes for specific requirements and guidelines.